Welcome to HP Tuner's Ford Mod Motor Training Part 17. In this video, we're going to be taking a look at working with our Transient Fuel Tuning and our Ford PCM programming. Our Transient Fuel Tuning is going to be when we have rapid throttle changes, whether it's going to be a large throttle input or when we snap the throttle shut on lift throttle conditions. We're going to have an alignment when we close our throttle and an enrichment when we open our throttle. Now, if we have something slightly out within our modeling between airflow and fuel, we might find after we're done doing all of the tuning and completed everything that we have some kind of a fuel discrepancy that we need to take care of in our transient tables. I'm going to go show you how to go and tune them properly using log data from our VCM scanner so we can pinpoint the areas of a concern and go back into the appropriate tables and make our adjustments. Without further wait, let's jump into our video so we can check this out. Okay, so let's get started. We're going to be taking a look at working with our transient fuel calculations that are being performed in our Ford PCM programming. The transient fuel is one of the last things we have to calibrate within our fuel calibration process. There's some specific things that we need to know about it, so we're going to be discussing those within the video and then taking a look in our VCM scanner at some log data so we can determine what kind of changes we need to make and where we need to make them in the calibration process. So first things first, let's open up a calibration file. I'm going to go here to File Open and then move into our calibration file examples. I'm going to go and grab a stock 2005 Mustang GT 4.6 liter. Let's go click Open here. Now we're going to go into Engine, and then under Engine here, we're going to find, moving from General into Airflow and then into Speed Density, we have a parameter called Dynamic Airflow Manifold Volume. This is going to be one of the main driving factors for the transient fuel. Now the transient fuel is going to be used when we have large throttle rate changes in the positive direction. So if we start to have, let's say we're going from 10% throttle to 60% throttle, we're going to have a pretty large burst of airflow that the mass airflow or the speed density calculations may not be able to compensate for, meaning they might not be able to characterize that burst of airflow. And we need to fill in the blanks, and that's what the transient fuel is going to do. It's going to take a look at the throttle pump effect from having a large throttle input as we're driving around. Now the dynamic airflow manifold volume is going to be essentially a gain or a multiplier to the entire enrichment process within the transient fuel. So this is going to be, think of this as an overall fuel trim within transient alone. Now, we also have a second area here called fuel, and under transient, we have specific areas to deal with an enrichment and an alignment. So the enrichment would be when we're trying to apply fuel, when we're having a rapid throttle change, that'll be taken care of in our acceleration portion. Then we have a deceleration portion. This is what's known as our alignment, or when we lift throttle very quickly, sometimes we might have too much airflow registration, or in the airflow and fuel modeling, it might just be too much. And we find that on those quick throttle snaps, so we shut the throttle very, very quickly, we're going to find that it runs too rich. And we need to clean that up because our generalized airflow model here under our speed density calculations or on the mass airflow calculations, again, can't fill in the blanks. They can't completely characterize that condition. And that's where we have both the alignment and the enrichment aspect. So we have these three different areas to deal with and start to calibrate. Let's go in here and talk about our airflow under speed density and manifold volume first. So manifold volume is going to be the volume of the actual intake manifold itself. What this is actually representing is a time factor or multiplication factor within the transient fuel. If we start to lower down the manifold volume from, let's say, 10.9 to 8 liters, that's going to be telling the PCM that it needs to react quicker to apply our transient fuel, and it also needs to be a bit more aggressive when it's doing a multiplication within the background. So every time we go in and reduce the manifold volume, we'll find that the transient fuel will kick in quicker and it'll have a higher magnitude of a multiplication factor against whatever the injector pulse width being calculated, either from a speed density calculation or from our mass airflow curve here within our airflow modeling. So again, we'll represent whatever the airflow is going to be. We'd represent what the command at lambda is going to be from our base fuel table, wherever we're riding at. And then we're going to find that knowing the air mass, knowing the target lambda or target air fuel, we'll know what the fuel mass should be. It'll figure out and convert the fuel mass into an injector pulse width, going through all of our fuel calculations, whether it's going to be low or high slope or looking at our offset. It's going to be combining all of that to give us an injector pulse width to deliver. Then we'll find it has a multiplication factor beyond that, which is going to be coming then from our manifold volume here. So this plays a role, again, not only how quickly transient fuel kicks in, but also the magnitude of the multiplication factor against what we're finding the injector pulse with is going to be calculated through our normal fuel and air mass modeling. So what we'll find here, and as in most situations, we don't need to touch manifold volume. However, if you're finding at low engine speeds or high engine speeds as you're driving around and you're giving throttle inputs, it doesn't drive very smooth. And if you're looking at your wideband, it seems like it's going to be showing that it's always constantly going lean as you blip the throttle. That's going to be a dead indication that you may have to drop down. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.